Hello students, in this video we will start with the fourth chapter in Science 1, that is measurement of matter. Now do you remember what is matter? Matter is any substance that has mass and take up space by having volume. Now do you remember about atoms that we studied last year in 8th standard? You have also studied about different theories which were given by different scientists. For example, the Dalton's atomic theory, Rutherford's atomic theory, Bohr's atomic theory, and so on. Now, you have studied about the compounds and how they have formed. This year you will be studying more in detail about the matter and how we measure or calculate the matter. Next is the law of chemical combination. Now, many scientists have studied about these chemical combinations and they have given a law, and the law states that there is no rise or drop in the mass of matter during a chemical reaction. Now we all know that when a chemical reaction takes place, that means the reactants, they form a product. So here two reactants will combine together, and when they mix together they form a product which is formed. Now this product and the reactants which are there, when you will calculate the mass is same. You will find that there is no difference in the mass. So for example, in this test tube, we have sodium sulfate. This is the solution of calcium chloride. So when sodium sulfate and calcium chloride combine together, what we get is CaSO4, that is calcium sulfate, and NaCl, that is sodium chloride. So these two things are formed. And when we will weight it, that before when they were mixed together, the weight is 67.25 gram, and after forming two different things, the weight is 67.25 gram. So this gives us the law of chemical combination, or you can also say the law of conservation of matter, which states that the reactants and the products are same. The weight of reactants and the product do not change. So there is no rise or drop in the mass of the matter during a chemical reaction. The scientist who gave the law of conservation of matter or the law of chemical combination is Antonio Lavoisier. And he has also given many different research, but this was a very important research that he had given to us. Another law is law of constant proportion. Now what this law states that the proportion by mass of the constituent elements in the different sample of a compound are fixed. So this means that the proportion of the mass is always fixed for some few elements. For example, we will look at the proportion of mass of hydrogen and oxygen in water. Now we all know that water is formed by hydrogen and oxygen. When oxygen and hydrogen combine together, that is H2O, that time water is formed. So when these things are formed, that is when hydrogen and oxygen is combined in water, that is when water is formed. So from any source it is 1:8. That means one part is always hydrogen and 8 parts are oxygen. So if 9 gram of water is to be formed, okay, so in 9 gram, 1 part will be hydrogen and 8 parts will be oxygen. So that means in 9 grams, 1 gram is hydrogen and 8 gram is oxygen. So in this way, the proportion is fixed for every substance. If you will take carbon dioxide, so for carbon dioxide also the proportion is fixed. If you will take NaCl, for that also the proportion is fixed. So for everything, the proportion by mass is fixed for all the constituent elements. When they combine and they form compounds, the proportion is always fixed. For example, जो हमने यहाँ पे देखा कि for oxygen and hydrogen, when it forms water, it is 1:8. So for example, I say it is 10 gram of water. So then 1 gram will be hydrogen and 9 grams will be oxygen. Same way if it is 11 grams of water, so 1 gram will be hydrogen and 10 grams will be oxygen. Now you may think that from where 1:8 came. So for that, we have to find out about the atomic mass of hydrogen and oxygen. So a molecule of water contains, that is, if you will see a molecule of water, the formula is H2O. That means two atoms of hydrogens are there and one atom of oxygen is there. This proportion remains the same no matter what the source of water is. We all know that always the proportion of water will be same, that it will be always H2O. It never becomes H23 or H3O or H4O. No, it is always H2O only. So we know the atomic mass of hydrogen is 1 and that of oxygen is 16. So now we have, for example, the water, it has two molecules of hydrogen. So that means 1 into 2, that is 2 hydrogen, and we have one molecule of oxygen. So 16 into 1, which is 16. So that means the ratio becomes 2:16. And when you will reduce it, so this becomes 1:8. So this is how we got 1:8. By knowing the atomic mass of hydrogen and oxygen, we come to know what is the proportion of that particular element. Let's look at another example. Now find out the ratio of nitrogen and hydrogen in ammonia. So now we have to find the ratio of nitrogen and hydrogen in ammonia. So if you will see, the formula for ammonia is NH3. So that means if the atomic mass of nitrogen is 14, so ammonia has one atom of nitrogen and three atoms of hydrogen. Why? Because the formula is NH4. One atom is nitrogen and three atoms are hydrogen. So N is 1, formula is 14, that is the atomic mass is 14. So 14 into 1 is 14. Next is what? Hydrogen. How many atoms are there of hydrogen? That is, we have 3 atoms of hydrogen. So 1 into 3, which is 3. So what we got? The ratio of nitrogen and hydrogen. Nitrogen what we got as 14 and hydrogen we got as 3. So this is the ratio that we got, that is 14:3. So I guess you must have understood. Now you cannot reduce this more, it do not go in the same table. So that means the ratio of ammonia is always fixed, which is 14:3. Now what you can do is calculate the mass of nitrogen and hydrogen in 34 grams of ammonia. So what you will do is, from 34 grams, 14:3 you have to divide in this 34 gram as we did for oxygen. Do it in your rough books. Now here are few terms which you have studied in your previous class. For example, first is the atomic mass number. So do you all remember what is atomic mass number? The number of protons and the number of neutrons in the atomic nucleus is called as the atomic mass number. Next is the relative mass of an atom. Now, the relative mass of an atom is nothing but then atom is taken to relate it with other atoms. For example, earlier hydrogen was taken as the mass of hydrogen is 1. So it was accepted to compare it with other atoms. So for example, the mass of one nitrogen atom is 14. So that means 14 times that of hydrogen atom. So 14 into 1, which is 14 only. So therefore, the relative mass of nitrogen becomes what? 14. So this is nothing but the comparison. So earlier hydrogen was used, but these days we use carbon because it is more stable and the mass of carbon is 12. That is 12 is relatively accepted and it is widely used. So this is called as the relative mass of an atom, a particular atom that we relate it with other atoms. We compare it with other atoms. Next is the unified mass, which is nothing but the standard unit of the atomic mass that quantifies mass of an atomic or the molecular scale. So for example, we use that U, and 1 U is equal to 1.66053904 into 10 raised to minus 7 kg. So if you have to find the answer of 2 mu, then you'll have to calculate 2 into the number multiply by 10 raised to minus 27 kgs. Another thing is the history and need of chemical symbols. Now we all know that there are symbols given to all the elements which are there in the periodic table. So now these elements are given the symbols according to the IUPAC nomenclature, and this is the International Union of Pure and Applied Chemistry. They give the symbol to the particular element, and these symbols, they are according to the first letter of the name of that element, and if first letter is already taken, then the second letter is given. So first letter will be in capital, second will be in small. For example, if helium, you will see, if you will see the symbol of helium, it is capital H and small e. So as H is already given to hydrogen, so that is why helium also starts with H. So spelling of helium is HELIUM. So to give the symbol, we have taken H as capital and E as small. So this is how we give the chemical symbol. Now there is a need to give chemical symbols, so that we do not get confused while reading them, while identifying them, and while studying about them. Next is molecules of elements and compound. Now, if you will see a particular element or compound, they exist in different states. There can be monoatomic state, polyatomic state, diatomic state, and so on. Now, monoatomic state means, for example, if you will see helium, neon, they are independent. They exist independently. So that is why they are called as monoatomic state. They have monoatomic molecular state. Then if you will see oxygen, so the molecular formula for oxygen is C, that is O2. For nitrogen, it is N2. So that means they exist in diatomic states. Now some of the elements, they exist with 2 or 3 or 4 atoms together. For example, NH4 and other examples. So these things exist with polyatomic states. That means there are more than 2 or 3 atoms of an elements will combine and they form a molecule. So these are called as molecules of elements and compounds. They exist according to their states.